So what's going on everyone, welcome to this video tutorial. In this tutorial we have brought for you diagonal difference solution. This is a problem in HackerRank in problem solving section. So let's start solving it. As you can see on the left side of the screen, you have the problem statement. You have to read it once. So what this problem statement says in brief is that you will be given a matrix, or we can say a two-dimensional array. You can see the example here: 1 2 3 4 5 6 9 8 9. You will have to find the sum of its diagonal and anti-diagonal elements. So as you can see, the left diagonal will be 159 and the right diagonal will be 359. So to understand the problem clearly and how to proceed to solve any problem, let us visualize it and see how two-dimensional array is represented in memory. So you can see here we have a matrix. These are column indices and these are row indices. So for example, if you want to access phi from this matrix, what you'll have to do is you'll have to access it through its row index and column index, written in order. So in the next table you can see how we can write the row index and column index for each and every data element. Let's say we have an array A. So if you want to access an element 1 in an array A, what you will do is A of 0 0, that is 1. You will write the row index and then the column index like this. A of 0 0 is equal to 1. A of 1 0 is equal to 4, that is A of 1 and 0, that is 4 here. So similarly you can access the elements. Now in this question, what we have to do is we have to find the diagonal elements. We want to access all the diagonal elements and its anti-diagonal elements. So what we'll do is we'll see if we can find any sort of pattern in the diagonal. We have a pattern 0 0 1 1 2 2. So if we consider I as row and j as column, then for all the diagonal elements we'll have I is equal to j. So whenever in a matrix I will be equal to j, we will get diagonal elements. Now let's see what happens for anti-diagonal elements. You can see the I value, that is the row value, 2 1 0, or you can go around like 0 1 2. So as you can see, it increases 0 1 2 up to n minus 1 elements. And for j, that is column 2 1 0, it decreases from n minus 1 to 0. So you got some sort of pattern in diagonal and anti-diagonal elements. So this last table basically shows you is that I and j, for example, are two variables. From I we are accessing all the row elements, and from j we are accessing all the column elements. So it makes our task easier. So let us see how we are going to do it. Coming back here, now we'll start writing our code. So first of all, we'll store the size of array in n. Now what we'll do is we'll take a variable diagonal and assign it to 0, and anti-diagonal and assign it again to 0, so that we can store its sum in this variable. Now we'll run a for loop. This problem can be done in two for loops also, but to reduce its time complexity, we'll be doing it in one for loop. So for diagonal elements, we know I should be equal to j, that is all these elements, s diagonal here I because when I will be 0, it will be 0 0. I will be 1, it will be ARR of 1 1, then 2 2. So basically it will calculate the sum of 159 0 0 1 1 and 2 2. For anti-diagonal, what we'll do is we just saw the pattern of diagonal and anti-diagonal. Diagonal was pretty simple. Now what about anti-diagonal? Let's have a look at it again. In our problem, we are just doing it with one for loop, that is with I only. We did it for diagonal, that when I is 0, j will also be 0. We did it with one for loop, 0 0 1 1 2 2. Now what about anti-diagonal? So as you can see here, we have 0 to 1 1 2 0. You can see the row elements are increasing from 0 1 2 up to n minus 1. So here we have a matrix of order 3. So it is increasing up to 2, that is n minus 1. And similarly the column elements are decreasing to 0 and starting from n minus 1, that is 2. So we will follow the same logic with our code for column elements which are decreasing. So what we'll write here is AR of I, because I is increasing from 0 to n minus 1. In place of column, what we'll do is we'll write n minus 1 minus I. So for example, when I is 0 and n is 3, j will be 2, 0 2. So you can, when you calculate it, you'll come to know the order of this anti-diagonal. You can just put in the value of I and calculate this anti-diagonal elements. So this is how it will be done. Now let us take another variable called sum and assign it to 0. So sum will be equal to absolute value of diagonal plus anti-diagonal. No, it will be minus, yeah. Return sum. And yes, I has to be declared yet. Okay, so we wrote wrong variable name. So we got the correct output. Now let us submit the code. So as you can see, we submitted the code successfully. So this is how we can do absolute difference of diagonal elements of a matrix. So that's it for this video. Thank you and have a nice day.